All right, this is my neural network that classifies handwritten digits from the MNIST dataset. This dataset comes from the U.S. National Institute of Standards and Technology, and the digits were collected from 250 individuals, making the digits diverse in the ways that they come in, which is especially good for our training and testing purposes. Additionally, this dataset consists of 70,000 images in total, 60,000 of them being for training purposes, while the remaining 10,000 being for test purposes. So first, to walk you through my model, I'm going to transform and compose my data, and then I'm going to make a train set, a test set, a train loader, and a data loader, and I'm going to basically initialize where my data is coming from, if I want it to be trained, if I want to be transformed, my batch sizes, and the randomization of data, which is the shuffling keyword. So this is my neural network right here. It's a vanilla feed-forward neural network, and it has 3 layers: the first linear layer, the second linear layer, and the final layer with the value activation. In the forward method, I'm going to convert and flatten my image so it can be suited for the neural network, and I'm going to use cross-entropy loss and atom as my optimizer. I have 10 epochs here, which works fine for this particular model, but you have to be careful when selecting your epochs because too many can lead to overfitting, while not enough can lead to underfitting. And right here, this is where I'm going to calculate my loss and train my neural network. And over here, this is what I'm going to do with my test data. I'm going to do it without any gradient, and I'm going to evaluate how well it works. And I have my visualization step here because I want to see what digit the neural network is classifying and verify if it's correct. I've actually pre-ran this on my computer because I am running my neural network on Pytorch on my CPU, which would take a little bit of time to run. So to speed up time, I just ran it prior to this video. So this is the image right here that is showing up in the visualization, which means that our neural network is going to predict what digit this is. So I'm going to open up my terminal, and right here the tensor says 6, and this image happens to be a 6, which means that our neural network predicted the correct digit number for this digit. And my model for this particular round has an accuracy of 0.973, which is pretty great. Thank you very much, and this is my neural network.